Implement a push function, two push functions one by one. So let's do push back, which is the same as a push of previous non-double-ended queue version. So let me clean the screen. Then what we are going to do is as follows. So we have a queue object. We will have a primarily two pointers, front and back. As we create a node, now node has three members: data, next, and previous. So at the very beginning, when queue is created, queue back is a null pointer, front is null pointer point, and then count is 0. And as you do push back first time with the data 5 is stored, and then this will be both front and the queue there. So we'll have a link something like front, back, the same guy, and then this is next member is nothing there, previous member is nothing there. So that's the first push, and then as you do push one more time, push back one more time, what we need to do is create node, data is stored, and then next member and previous member. Next, there is no next, that's fine, but the node with the 5, now next member means this is next guy. And then the new node with the 6, now this guy has a previous pointer, so we should point it to the node with the data 5. Then if this is a pointer to back of the queue, this should be updated with a new one just entered. So comprehensive case enumeration, left and right hand side, what we add if currently queue is empty, it means the length is count is 0, then left hand side is queue, right hand side is nothing. But if it's not empty, at least one or more data is there. Left hand side is a node, right hand side is null. So we have two cases, same as the previous queue implementation. Based on that, let's write the code. So deque, let's do push back, integer data is there, and implementation void push back int data is there. So first, let's create a new node with the data wrapped by that. So if count is 0 or length function call is 0, then we take care of the first case. That is the one just created becomes a front and back. So p front, p back is a new node just created. And otherwise, we need to do in this case. So in this case, p back currently is this node. P back next member should be the new node. So p back of the queue next member should be the new one just created. So we establish this link. So currently p back is pointing to this node, existing node, and this need to be updated. Then the new node just created, a previous guy is p back. So we establish it. So new node, previous member is pointing to the current, the new node. This is a p back, and then now back of the queue is a new node just created. So we establish this link. Then at the end, we of course need to update the count. So that's a push function. we are unable to test the push function except for length. So in the next video, let's test the pushback function together with some data reading functions as well.